I want to go over some practice problems on problem set 1. And so we talked in an earlier video about the steps to draw a Lewis structure. So we're going to go ahead. Step 1 is count the number of valence electrons. We know that carbon is in group 4, and so it's going to have 4 valence electrons. Hydrogen is in group 1, and there's 3 of them. So there's going to be 3 electrons from those 3 hydrogens. And so nitrogen has 5 electrons, and then those 2 hydrogens, there's 2 of them, and they have 1 electron each. That gives us a total of 14 electrons. And so the next step is to draw heteroatoms and carbons on the inside. So I'm going to start with my carbon. I'm going to give it its 4 valence electrons. It's in group 4 of the periodic table. And then nitrogen, I'm going to give it its valence electrons, and going to go ahead and start connecting and forming bonds. And so I'm going to put the H's on the outside. So step 2 is to put the heteroatoms and carbons on the inside and the H's on the outside. And so I have 2 H's for the nitrogen and then 3 H's for the carbon. And so I'll put the H's on the outside of that carbon. And then step 3 is to count and see if everything has the octet. So the carbon has 4 bonds around it. Each bond has 2 electrons. So that has a total of 8 electrons. And so that fills the octet. And the nitrogen has 2, 4, 6 from the 3 bonds. And so that fills its octet because it has also those additional 2 lone pairs for a total of 8. And so the nitrogens are happy, or the nitrogen's happy, the carbon's happy, and then each of the hydrogens have 2 electrons in the bond that it's attached to, and so they get a duet, and therefore they get satisfied because of the helium configuration that it attains. And so that's the first problem. This is the correct structure. Now, I'm going to go ahead and put this in red because I believe something like this will definitely be high yield. And so you guys want to make sure that you understand something like this. A lot of the content we've covered so far is pretty basic. And so we've done examples of CH4 and drawing the Lewis structure for that. That would not be high yield. That would be low yield. That's not likely to be on an exam. It's too simple, straightforward. It's basically a building block to teach you more complex concepts, but it is not itself testable. And so, yeah, you do need to know it, but it's not something that you would see on an exam. And so I'm going to start to make that distinction. I'm going to go ahead and I'll mention this in other videos as well. Red would be high yield, something you really need to know. And then yellow would be low yield. And so I'm going to keep that distinction so you can get an idea of what's testable and what's really just for background information or building blocks to higher concepts. And so the second problem we have is CH3. OCH3, and so again I'm going to do the same thing. I know that this has 4 electrons. I know that this has 1, and there are 3 of them. I know that the oxygen has 6 electrons. I know that that carbon has 4 again, and I know that I have 3 here. There's 1 electron in each. So if my math is right, I think I'm at 20, if I'm not mistaken. So you have 10 here plus the 4, 17, 20. So 20 electrons. And so now what we're going to do is we're going to put the heteroatoms and carbons on the inside. So I'll put a carbon there, and I'll put the 4 valence electrons on it. I'm going to put my oxygen in the middle, and I'm going to put the 6 valence electrons on it. And then lastly, I'm going to put the last carbon with its 4 valence electrons. I'm going to start to form bonds, and then I'm going to recognize that, hey, I have 3 hydrogens, and I'm going to place them on the outside of the carbons. And again, I'm going to place them on the outside of the carbons. And so what we have here is the final Lewis structure. I'm going to count my electrons around carbon. So I have 8, 2 in each bond. I have 2 bonds, 2 each, and then 2 lone pairs, so a total of 8 on that oxygen. So this one's happy, and that carbon again, 4 bonds each with 2. It's going to have full octet. So all of the heteroatoms and carbons are satisfied, and then the H's have their duets, so they're satisfied. This is the correct structure. Again, something like this would be fair game on the test, and so I would need to know this. The next problem that we have is CH2O. So we're going to get a little bit more into variations of possibilities. And so what we're going to do is we're going to, again, 4 electrons here, 1 times 2, 4 there, and then lastly 6. So we're looking at 16 electrons. And I'm going to go ahead and draw this over here, and I'm going to put the heteroatoms and the carbons in the middle. So I'll just go ahead and slide over. And so I'll start over here. And so I'll put C with its 4 valence electrons. I'll put another C, and then I'll put an O. And so C has 4 valence electrons, oxygen has 6 valence electrons, and then I have 2 hydrogens. So I'll stick the hydrogens right here. I make that assumption that I'm sticking the hydrogens on this last carbon because that's how they're oriented there. I may or may not be correct, but that's how I'm essentially going to start with. I'll make that assumption and then correct it if I need to moving on. And so I'll put the hydrogens again on each side here. Okay, so this is my structure. So what I can do now is I can essentially put this there and that there to form a double bond. So I'll have C, C with the H and the H. And then now I have still a lone pair there, and then okay. And so what I can do here now is I can go ahead and take that radical or electron, excuse me, and bring this here and bring that there. That's a bad way to draw it. They don't need to crisscross, but if I redraw that over here on top, I would get now this as my final structure. And that would be totally fair game for an exam. And so these are the things that you need to be thinking about when we practice. Just going through and knowing that, okay, it's very likely that these 2 H's are on that carbon. When I see a CO, it's very likely this structure. You're going to pick up these patterns as we move forward. So I'm not going to put an R group there because we kind of haven't talked about R groups yet. But the idea is when you see it with CO, it's likely going to have that. So these are the answers for the first 3 problems.